Ever wondered if your pocket-sized hacking tool could literally see threats before they strike? Imagine a world where your Flipper Zero isn't just a versatile multi-tool, but an intelligent, AI-powered sentinel. By marrying the cutting-edge power of YOLO's real-time object detection with the Flipper Zero's incredible hardware versatility, you're about to build something truly revolutionary, a mobile AI security sentinel that fits right in your pocket. YOLO, or You Only Look Once, is a groundbreaking real-time object detection system. It's renowned for its speed and accuracy in identifying objects within images or video streams. This makes it an indispensable tool for everything from autonomous vehicles to advanced surveillance systems. On the other hand, the Flipper Zero is a hacker's best friend, a true Swiss Army knife for security professionals, hobbyists, and DIY enthusiasts alike. Its capabilities span RFID, NFC, sub-GHz, GPIO, and more, making it perfect for penetration testing, hardware hacking, and security research. Combining these two powerhouses creates an unparalleled synergy. You gain instant, intelligent object detection capabilities, allowing your Flipper Zero to perceive its environment in a whole new way. This opens up a universe of possibilities for automated security enhancements and innovative hacking projects. Think about it. A portable pen testing kit that can visually identify targets, or a DIY security system that alerts you to specific objects. This integration empowers you to act on those detections, whether it's simulating RFID attacks, automating responses to detected devices, or enhancing your overall security posture. It's about transforming theoretical knowledge into practical, deployable solutions. Let's dive into the practical steps to bring this vision to life. Our journey begins by setting up the YOLO environment, and Google Colab is our ideal playground. It provides free GPU access, making complex machine learning tasks accessible to everyone, from students to seasoned developers. First, you'll need to clone the YOLO 5 repository directly from GitHub. This is your foundational codebase. Use the command git clone https github.com ultralytics YOLO 5 in a Colab notebook cell. Next, we install all the necessary dependencies. YOLO 5 has a well-defined set of requirements, and pip install rrequirements.txt will handle everything automatically. This ensures your environment is perfectly configured for training. Finally, the crucial step for custom detection: uploading your dataset. This dataset will contain images and corresponding labels for the objects you want your Flipper Zero to detect. Organize your data meticulously. Quality data leads to superior model performance. Now, for the exciting part, training your very own custom detection model. This is where you teach YOLO to recognize specific items relevant to your security or hacking projects. Imagine training it to spot unauthorized devices, rogue RFID cards, or even specific types of network hardware. Begin by editing the data.yaml file. This configuration file defines your custom classes, such as unauthorized device, rogue card, suspicious object, or network tap. Each class represents an object your model will learn to identify. Once your data.yaml is configured and your dataset is ready, launch the training process with Python train.py, img640, batch 16, epochs 100, data.yaml, weights YOLO5s.pt. This command kicks off the learning phase, where the model analyzes your images and adjusts its internal parameters. During training, it's vital to monitor the loss and mean average precision, MAP. These metrics provide real-time feedback on how well your model is learning and performing. A decreasing loss and increasing MAP indicate successful training, ensuring your model is robust and accurate. The trained model is powerful, but it's not yet in a format the Flipper Zero can directly use. We need to optimize and convert it for deployment on embedded systems. This step is crucial for practical application on a resource-constrained device like the Flipper Zero. First, export your trained model to the ONX format. ONNX, Open Neural Network Exchange, is an open standard for representing machine learning models, making them portable across different frameworks and hardware. Use the command python export.py. Weights runs train exp weights best.pt include ONNX. Next, we convert the ONNX model into a Flipper Machine Learning, FML, format. This specialized format is optimized for the Flipper Zero's hardware and firmware. You'll typically use a custom tool or script provided by the Flipper Zero community, or a dedicated utility for this conversion, such as FML convert model.onNX. This ensures maximum compatibility and efficiency. This conversion process is a key step for DIY security enthusiasts and developers. It bridges the gap between powerful cloud-based training and practical on-device execution. The result is a compact, efficient model ready for deployment. With your model converted to the FML format, it's time to transfer it to your Flipper Zero. This is where your digital creation becomes a tangible, portable security tool. The process is straightforward, making it accessible for anyone in the DIY community. Connect your Flipper Zero to your computer via USB. Ensure it's in mass storage mode or accessible through QFlipper, the official Flipper Zero desktop application. This allows you to browse its file system. Copy the generated FML file directly to the Apps AI directory on your Flipper Zero's SD card. This is the designated location for custom AI models and applications. If the directory doesn't exist, create it. Once the file is transferred, safely eject your Flipper Zero. On the device itself, navigate through its intuitive UI to the AI application or the custom app you've developed. Launch the Detection app, and your Flipper Zero will now be running your custom AI model, ready to identify objects in its environment. Now let's witness the power of your combined YOLO and Flipper Zero setup in action. This is where the theoretical becomes incredibly practical and exciting. Imagine the possibilities for security professionals and hobbyist hackers. Picture this: your Flipper Zero equipped with your custom AI model, scanning an RFID card. It doesn't just read the data, it visually confirms the card type or even identifies a specific rogue card you've trained it to recognize. This enhances access control auditing and penetration testing. Consider perimeter security. Your Flipper Zero, perhaps connected to a small camera, can now detect moving people or specific objects entering a designated zone. It could then trigger an alert, log the event, or even initiate a sub-GHz transmission to a connected device. This is automation at its finest. Furthermore, imagine using it for incident response. Your Flipper Zero could visually identify unauthorized USB devices plugged into a computer or detect specific network taps. This provides immediate, on-site visual confirmation, significantly speeding up your response time. The implications for real-world security scenarios are immense, offering a new layer of intelligent awareness. To truly maximize the potential of your Flipper Zero AI Sentinel, optimization is key. For tech enthusiasts and developers, understanding these techniques will unlock peak performance and efficiency. It's about getting the most out of limited resources. First, consider model pruning and quantization. Pruning removes unnecessary connections in the neural network, while quantization reduces the precision of the model's weights. Both techniques significantly reduce the model's size and computational requirements without a major loss in accuracy, making it ideal for embedded devices. Next, tweak the batch size during inference. A smaller batch size can reduce latency, which is crucial for real-time applications. Experiment with different values to find the sweet spot between speed and resource usage for your specific Flipper Zero setup. Finally, for power efficiency, implement sleep mode between scans. If continuous detection isn't required, configure your Flipper Zero to enter a low-power state between detection cycles. This dramatically extends battery life, making your portable AI Sentinel truly long-lasting and practical for extended deployments. You've just unlocked a new dimension of security and hacking capabilities. By combining YOLO's visual intelligence with the Flipper Zero's versatile hardware, you now possess a portable AI defender, capable of seeing and reacting to its environment in ways previously unimaginable. This is the future of DIY security and intelligent penetration testing right in your hands. Which scenario will you secure first with your new AI-powered Flipper Zero? Will you build an automated perimeter defense, a smart access control auditor, or something entirely new? Drop your innovative use case in the comments below. We'd love to hear your ideas and see what incredible projects you're cooking up. If you found this guide informative, technical, and inspiring, please smash that like button. Don't forget to subscribe to the channel for more cutting-edge tech guides, hacking projects, and practical security enhancements. Share this video with your fellow tech enthusiasts, security professionals, and DIY community members. Let's build the future of intelligent security together.